definitely more and more data coming in. I think when we're thinking about faults, a lot of the data we have comes from earthquakes themselves. So by looking at the location of earthquakes, you can infer the position of faults. And the data sets are really becoming much better and much more complete than they used to be. And that's due to a combination of improvements in the instrumentation. So people put down better seismic networks. They put them down in places where we didn't have any network before. And then recently with machine learning, there is also a push towards basically finding more signal in the data that we already have. And so people have been coming up with much more complete earthquake catalogs, where you can see many more earthquakes that you could see before. And this is very useful also for people like me who work on modeling and theory, because it really gives us much better data to constrain our models and to test hypotheses in some cases. So it's definitely a field that's expanding. I would say the two main types of data to understand fault behavior are seismic data and geodetic data. Geodetic data meaning satellite data that allows you to look at the deformation on the surface, and then you can invert for the deformation at depth. So for example, if you have slip on a fault at depth, it will result in a certain deformation pattern on the surface, which you can then look at to infer what happened at depth. There is an entire class of phenomena happening on faults which are not seismic. Sometimes faults slide abruptly, and that's an earthquake, but sometimes they slide very slowly in such a slow way that they don't produce any seismic waves. And so in that case, geodetic data is what you need to look at in order to understand the deformation at depth. Earthquake prediction is not a term it's a very loaded term in my community, not one we use lightly, and many of us, including myself, think that earthquake prediction may never be possible. If you define prediction as a very specific statement about the location, the time, and the magnitude of an earthquake, that may just not be possible. What is possible, and it's routinely done already, is earthquake forecasting. This is a probabilistic statement in which you're looking at likelihood of an earthquake over a certain period of time. And some of my research is very closely related to this problem, both when I looked at aftershock sequences during my PhD, but now also some of the research on foreshock sequences. We're always hoping that by better understanding the physics behind these signals that we may see in earthquake catalogs or in deformation data, we may one day be able to express time-dependent earthquake probabilities, and that's basically the definition of operational earthquake forecasting. So that's one aspect of that is very important for my research, and one that I hope to contribute to in the future.